Today we'll be starting a new chapter, Numbers and Functions. So we'll be reviewing some kinds of numbers that were introduced in other classes. We'll be renaming them, making sure you know the specific names and what numbers fall in each set, along with how they relate to functions. In this first section, today's learning goals, you can see identify and use properties of real numbers, and to evaluate expressions by using the order of operations. Two things we have done in previous classes, so it's more let's just review and do a little more in-depth work. So, starting with, do you know? Now, do you know means not just have you heard of. Can you define and list the set of each of the following number types? So, you've heard of natural numbers. Natural numbers are also commonly called counting numbers. So if you know the natural numbers, you know the counting numbers. Whole numbers, a different set. Integers, a third. Rational numbers, irrational numbers, real numbers. All 6 sets are different types of numbers you have worked with, you have calculated with, and you should know what falls in each set, be able to define it in words, and also write a short list or an infinite list or whatever kind of list it is, maybe in a shortcut way, because some of them are very large sets of numbers. So be able to do that, and we will be talking about that more in the class portion. Also, along with that, do you know the addition and multiplication properties? Again, can you identify them and name the different examples, show different examples, whether it's using numbers, variables, or a combination of both? So, do you know the closure property? That's one probably that's most vague due to previous teachers maybe didn't call it that, but we can discuss it during class if there's an issue. The commutative property, the associative property, the identity property, inverse, and distributive. The last 5 are a little more common, or at least have been talked about and discussed. You won't be needing to necessarily know them by name, but you will want to be able to identify them as which property represents which. If I gave you an example, could you say that's an example of the commutative property? Okay, so knowing that, let's go and talk about, this is a typical type of problem that you could be asked. Classify each number in as many ways as possible. And then you see some different types of numbers being listed here. Now these different types of numbers all would have been covered in those lists of numbers. So for example, the number in A, you should be able to tell me is such and such type of number. B is such and such type of number, belongs in this set of numbers. C, same thing. So naming all the possible names or number sets that these go into. And again, we'll be talking more about this during class and going back through it if you have some questions. But those are typical types of questions that you want to look for and look at. All right. Next, if we talk about problems, we want to write and justify each step in the simplification of this problem. So if we did this and we just focused on this, you're going to say, well, I know how to do that right now. A lot of you would say, hey, a binomial times a binomial. Okay, I just have to do, and whatever that blank is, that's what you want to do and that's what you want to verify. So if we write the steps and then justify, which I believe will be the harder part for most of you, we'll be done. So probably what most of you do first in the simplifying on this one is to think of it as R has to be multiplied by everything in that second parentheses, and S has to be multiplied by everything in that second parentheses. This is a first step. It's a common first step. It is not the only first step. this would definitely be an example of using the distributive property. So our justification there would be distributive property. Distributive property, if we want to say of anything, distributive property of addition, because there's addition involved in it, but we really usually don't separate distributive as addition or subtraction or addition and multiplication, right? Because there's a couple things going on using distributive property. Then the next step, we would individually distribute on each of those. The r out front of the parentheses has to be multiplied by the 5, the r has to be multiplied by the t, the s has to be multiplied by the 5, and the s has to be multiplied by the t. So you now have, again, 4 mini multiplication problems compared to the 2 you had up here. But that, again, is, if we justify, an example of the distributive property. And then last but not least, we start looking at those terms, and we know in algebra that usually when we multiply a number and a variable, that we like to see that number listed first. So we would rewrite this, put it in order, look for like terms, and that would be ordering, would be the commutative property. Change the order, but not change the answer. C as in commute allows us to change. So 5r is what came out of r times 5, r times t stays, alphabetical order rules, 5 times s, and s times t. If there was anything that was like terms, you could combine, but in this case there are none, so that is as simplified as you can get for this multiplication problem. Next, if we take those rules and apply them to problems that are a little more complex, we have to remember something called the order of operations. You've learned that. It was probably introduced as far back as elementary school, but you need to remember that there is an order to every problem that has multiple things going on. So, parentheses, grouping symbols, whatever you want to call it, need to be done first. Then powers, which are like exponents. Then you can do any multiplication and division from left to right, and then perform any addition and subtraction from left to right. You might have a little mnemonic, PEMDAS, pretty please my dear Aunt Sally, something that you've learned to help you remember that, but it has to be used. So in this example, we would definitely want to look at the parentheses first. So 11 plus 3 squared. There is no way you can add 11 plus 3 squared until you do the 3 squared. So in your mind, what's really happening on this one is you're saying, okay, 6, 11 plus 3 squared gets done first, which is your 9. Now you have parentheses. 11 plus 9 can be done, so that would be 6 times 20. Notice ignoring the 8 every single step along the way. And now last but not least here, 6 times 20, you could cancel if you wanted, but 6 times 20 is 120 over 8. If we do, 120 over 8, and then we can reduce. 4 goes into 120, 4 goes into 8, and after that you can see that's another name for 15. Second example. You see multiple parentheses, brackets, grouping symbols, and you always have to apply the innermost parenthesis or bracket first. So on this problem, we would be focusing on the innermost parenthesis first, and doing the innermost parenthesis. 6 minus 1 is 5. We could get a 5. Nothing else changes. The 3 stays where it's at. The subtraction there. We have a bracket, and we have a bracket down here at the end. Now looking at it again, we have parentheses. Innermost parentheses tell us we have a 5, but the 5 needs to be squared according to this. So we'd be looking at 3 times 5 squared is 25, and then 14 take away that value. And that whole thing will get multiplied by 2 eventually. So next, again, 3 multiplication needs to be done first in the parentheses, so 3 times 25 75. We have 14 take away 75. And some people will say, well, can't I distribute? You could, but since you have the arithmetic there, go ahead and do the arithmetic. And we would end up with a negative 61. And a negative 61 doubled is equal to a negative 122. So our final answer, solving that one, negative 122. We've done order of operations with multiple parentheses. You're going to see several problems like this in your work, and it would be best if you did these by hand to remind yourself what gets done first. And so we'll talk about that when we assign the homework. So bring any questions about order of operations and or the properties with you to class for our discussion. Good for today.